Welcome back from lunch to track 2 in the afternoon for Security B-Side San Francisco. Brought to you by HackerOne and Fitbit. Big thanks to our sponsors. You have to clap for the sponsors. I'm Andrew. This is Travis McPeak presenting When Bandits Strike, Defend Your Python Code. Without further ado, Travis.
Thank you. Thanks everybody for coming after lunch. Hope everybody enjoyed the pizza, the beer, and if you haven't had the awesome beer downstairs yet, do it. Very good stuff. And thank you for coming to my talk. Next door, Jim O'Leary is giving an awesome talk on metrics, which I was fortunate enough to see at AppSec Cali a couple of weeks ago. So for those of you that are missing his talk to be here, definitely check it out online. I had a lot of fun watching it. So I'm not going to do a lot of show of hands stuff, but can you raise your hand, please, if you are responsible for the security of Python code in some way? Cool. My people. I always like to start off with these with just giving an intro, just so you know how the flow of the talk's going to work. So we'll do intro, and then we're going to talk about how we can use Bandit to find some issues, and then finally building a program around Bandit and what I'd like to see happen in the future, and then we'll do Q&A. Sound good? Sweet. Who dis? I'm Travis. I love AppSec. I work for IBM Cloud. I'm heavily involved in OpenStack and Cloud Foundry security teams. In fact, the OpenStack security team, which we'll get to in a little bit, is why Bandit was created in the first place. We had some problems with Python code, and we wanted a tool to help find some of those problems. And I'm also heavily involved in OWASP Bay Area chapter. Any OWASP members? Last show of hands, I promise. Okay, good. OWASP is a very cool organization. If you love security, please check them out. We're actually having a happy hour tonight at Dirty Water at 5:30 to 7:30. So if you want to have some beer and hang out with cool people, please come by. Who dis? This is Bandit. I totally stole this logo. This is not Bandit's logo. I don't own it at all. Hence the disclaimer at the bottom. Bandit is open source, completely free to use. In fact, we encourage people to use it. And it's purpose-built. So I mentioned that we started doing this work with OpenStack a while ago. And in 2014, the type of issues that we were seeing, we suspected that you could just run grep across code and find things like command injection, use of weak crypto algorithms, and stuff like that. And so we actually started off with a grep-based approach. We were just like, okay, let's write some grep rules, find problems in Python code. And then we were at like a hackathon or something like that, and my boss at the time, a smart guy named Jamie, went away, thought about the problem, and came back with the initial version of Bandit. And since then, it has grown into the tool that I'll be talking about today. We have a few design goals for Bandit. We want it to be easily customizable. So there are different workflows that you might use. For example, you might use it as a penetration tester and just say, show me all of the things that might possibly be issues. Now, when you do that, it's very noisy, and so it might not be appropriate to run Bandit in the same way if you're going to do like a gate check job, for example. So we wanted it to be very customizable. And we also wanted it to be extendable. So we came up with a certain amount of tests that we thought would be useful to us, but we also wanted to make it easy to extend it for people that want to use the AST in Python to find their own security issues that maybe don't apply to our environment. And finally, we want it to be lean. I personally, and I assume a lot of you have had bad experiences with some static analysis tools in the past. Some of them are very bloated. They take a lot of space. You can't run it locally on a laptop very easy. And so we wanted Bandit to be something that is quick, runs across your entire code base without waiting half an hour, and gives you results that you can do something with. So what kind of issues are we talking about in Python code? Let's go through a few of them. First one is command injection. In Python, you'll see a lot of times people will just say, use subprocess to open something, and then you give it a command along with some input to the command and finally user input. And then you give it the magical shell equals true, which does what? Drops everything that you just put it onto a shell. And so you typically see things like this. If the user puts semicolon cat etcd password, it's horrible. You get wasted like this dog right here. It's bad news. Poor guy. Here's another example. People, for whatever reason, seem to like to hard code /temp paths, and the problem, of course, is that if an attacker can guess which temp file you're going to use, they can do all kinds of stuff. They can make it not usable to you, in which case your code might error out, or maybe they'll convince you to write something into it that you think is perfectly legit, and they have symlinked it somewhere else, and now all of a sudden you're causing data that you never intended to be written to a file. So there are secure ways of doing this. This is not one of them. And so when we see this, we want to flag it. Disable TLS certificate validation. TLS exists for a reason. There are a lot of things that you can prevent attack vectors by using TLS. And whenever you say verify equals false like this, you're saying forget about all that. Those TLS protections, we don't want those. You'll oftentimes see developers just doing it because they don't have certificates in their development environment, but they forget to change it back, and then guess what? All of the TLS protections that you thought you have, you don't have. Use of weak cryptography. This is not the 90s anymore. MD5 is totally broken. If you're doing anything security, do not use MD5 for it, please. So a lot of times you will see people doing stuff with passwords, storing them in MD5. They're like, okay, cool, hashing it, good job. But unfortunately, we have very fast computers nowadays, and it is trivial with cloud computing to compute a hash collision. Last example issue we'll talk about are promiscuous file permissions. I've seen a lot of developers just say, you know what, 777 should work. All of the permissions for all the things, it's fine. And then, the idea is that they'll come back and set something more secure later, but again, people being people, sometimes you forget. And so we look specifically for that last bit. Oftentimes you'll want your app to be able to access files that it's dealing with. But there's very little reason that you would want the world to be able to write to a file that you're dealing with. And so anytime we see world writable, we're like, okay, that probably doesn't look right. Let's flag it. Okay, so that's it for my very long-winded intro. Let's actually get into using Bandit to find some issues. So I mentioned in 2014 that OpenStack was not as secure as it is today. Part of the reason is because we used Bandit to find some of the issues. For example, in this case, we have basically a hard-coded admin credential to this web UI. And what that means, of course, is that you can't change it. It's just admin. So anybody that looks at this code knows exactly what your username and password is for the UI. And that's one of the things that Bandit can detect, is hard-coded credentials. In fact, actually, there's been some very cool work. Some of the people from Lyft use string entropy to detect credentials more accurately than Bandit does itself. It's not very sophisticated. It just looks for things that look like they might be passwords. Here's another example. In this case, they're using the temp file thing that I talked about. They're writing a SQL file over there to a fixed path, so it's always going to be temp create Uzi DB SQL, and then later on in the code, they're just executing that against their SQL database with the root user. So again, when you do stuff like this, wasted. It's not good. We were able to fix both of these issues and a lot more issues that we won't get into today by using Bandit. What I'd like to do at this point, rather than listening to me talk the whole time, let's find one together. Okay, so the first thing I'm going to do is I'm going to use my virtual environment. Whenever you're working with Python code, you want to do it in a virtual environment. Otherwise, all of the dependencies and stuff that you're dealing with get installed on your user account, and it gets very messy. So virtual environment, and it's got Bandit installed. Now, what I'd like to do is I'd like to run it against Ansible. Sorry, I said no more user questions, but you guys have heard of Ansible, right? It's a pretty popular orchestration framework. Okay, cool. And now let's run Bandit against it and see what we come up with. Just to explain what I've done here. So Bandit, I'm saying recursively scan the dot directory because I'm in Ansible. And I'm saying I want to exclude unit tests. We do that because anytime that we're looking at bugs, you want to be very careful that you're not creating noise where you don't need to be, and you don't want to tell developers about things that they're doing insecurely in code that doesn't make it in production. So let's just exclude the unit tests. And finally, to make sure we're getting good results, I'm using the LL and II filters, which LL is severity filtering and II is a confidence filtering. So what we're going to do when we get this is we're going to get all of the issues in Ansible that aren't unit tests that have a medium severity and confidence or higher. And you'll see it'll run fairly quickly. You're not going to have to wait long for this. This is one of the things that we like about Bandit. Developers can run this before they check in code. They can run it as part of CI. It's no problem. Okay, so here's one issue. It's saying the input method in Python reads from standard input, evaluates and runs the resulting string as Python source code. Well, that sounds kind of crazy. Does that seem like a reasonable thing that anybody else would want to do when they're calling input? Let's dig into that a little bit. Okay, so this is actually the code in Ansible. I dug it up and put it on a slide so that you guys can see it easier. And what they're doing is they have a prompt function. And what they do is they get user input and showing them the prompt that you have passed. But again, they might not think that the input here is actually going to be executed as Python code. I don't know about you guys, but that seems pretty sketchy. And when I saw this, I was like, oh, that's not what I would expect when I do input. So I looked it up in the documentation. And in fact, it's exactly what it does. It's equivalent to eval raw input prompt. Whoa, that sounds pretty bad to me. So what I did is I came up with a little example that we can run through to see what that looks like. So first of all, this is just a super basic script that uses the input function. It just says input, would you like a prize, and then that's it. That's the entire script. Let's see what happens when we run it. Would you like a prize? Yes. Okay, so it looks like it is actually trying to execute my input. That looks pretty sketchy to me. I wonder if we can exploit that. What if instead of saying yes, if I were to do something like this? You guys think it's going to work? It would be kind of a bad demo if it didn't work, wouldn't it? Holy shit, it just ran my password list and dumped it out. So you can't actually get command injection with this. Why am I showing you guys this? Is this me being super irresponsible and dropping O'Day on the Ansible project? It turns out it's not. I dug into it. I was like, wow, this is kind of a crazy bug. And they have code up earlier in the project that does this. It says, are we running in Python 2? If we are, then we need to use raw input, which is safer. And if we're running in Python 3, then go ahead, input's fine. So what I would like to see, if I'm running Bandit, I spent half hour, 45 minutes looking into this bug. It seems like it would make sense to put a comment here and say, hey guys, don't worry, we're not exposing this to untrusted user input that we're going to execute. And so what I would do if I was running Bandit on my project here, if Ansible was my baby, I would put a comment in here and I would say, don't worry, we've thought about this, and so the next person that comes along doesn't spend time wasting their time on this. Okay, let's switch gears a little bit and talk about how you might build Bandit into your program if you're responsible for a code base. This is the essential workflow. You're going to run Bandit, you find bugs, you're going to fix the bugs, you're going to end up in a state where there's no more bugs, and then you profit. Now, of course, the hard part in this whole thing was the remove bugs part. So let's talk a little bit more about how that works. Okay, so basically when we talk about removing a bug, we're going to do one of the following things here. We're going to use nosec, which tells Bandit, okay, a human's looked at this. It's not a security bug. Like, for example, we're using MD5 here just as an efficient hash algorithm. We're not using it for any security function. If you're talking about just non-security function, MD5 is great. You know, it's quick, it's efficient, you know, all of that stuff. There's no reason not to use it. And so if you're a security person, you dig into it and you say, it's fine, we're not doing anything with security with it. You can put a nosec tag and hopefully a helpful comment like I wish I would have had with the Ansible thing. And then from then on, Bandit will ignore it and people that come after you will say, it's cool, I looked at it. Another option is you can actually fix the bug, which in the case of the two that I showed for OpenStack, it's the right thing to do. You want to fix those, but unfortunately it takes some time. You can decide that the whole class of bug is not important to you. For example, there's a Jinja 2 plugin, and Jinja 2 has an auto-escaping feature. A lot of times Jinja 2 is used for templating in HTML. So you will take some template and you'll use that to put HTML to a user. Of course, you're worried about cross-site scripting when that happens, and Jinja 2 does have an auto-escaping thing that'll work, but a lot of times people disable it. Sometimes, maybe you're not using it to render HTML, and you could just say, it's cool, I don't care about cross-site scripting, and so you would say, for my project, don't worry about Jinja 2. So that's what I mean by here, by saying decide that the whole class of bug isn't important. Just say it's cool. The final option here is something we call Bandit Baseline. Bandit Baseline is basically, my project is full of 500 bugs right now, but I want to make sure that I don't get to 501. And what it'll do is it'll actually run Bandit against your parent commit, and then it'll run Bandit against your current commit, and it'll compare the difference. And if there's new bugs, then it says, okay, you're doing something right now that's going to create a problem for me. And otherwise, it'll just say, you know what, these aren't new bugs, so fix them when you can, but for now, it's okay. So that's kind of the options that you have when you talk about fixing bugs in your Bandit code. And then really what you'd like to do is you'd like to build a gate. You have any number of CI tools. I'm not necessarily shilling for Travis CI here. I just found it was an easy thing to set up. So you tell Travis CI, look at my repo, and then these 3 lines will do it. You say install Bandit, run Bandit, and then if you have a pull request on your repo, Travis CI will run Bandit and then put comments on the pull request so you know if there's new issues. Super simple. Okay, we are getting to the end here. I guess I just want to take a little time and go into some next steps. I feel like Bandit has pushed the marker forward for Python code, and what I'd really like to see at IBM, I'm responsible for a lot of code that's not Python. I would love to see resources like Bandit and the secure development guidelines that I'll show you in a minute for other languages. For example, Node. Tons of JavaScript on the server side happening. There aren't a lot of tools like Bandit that I've seen that are any good at analyzing Node, and there are not a lot of development guidelines that show you what you should be doing. And then metrics. I think that there's a lot of room here to extend Bandit and say, for example, let's say that the same development team keeps introducing bugs in Python code. Well, we could probably help them out with some training, and we don't want to necessarily give training to teams that are more sophisticated. So we can use Bandit to determine where we might need to spend a little bit more effort doing focused training. I mentioned the secure development guidance. This is something that we wrote for the OpenStack project, but I think it's going to be useful to anybody that does Python. Basically, it's a 5-minute explanation of a certain type of issue that you might see. It shows the incorrect and correct way of doing it. I think all of us have probably seen examples where somebody just copies some code from some guy on Stack Overflow or some girl on Stack Overflow, and it's just not good code, and then it ends up everywhere in your code base. The idea here was to create a place where you could copy the example code and it would be done securely. So that's exactly what we did here for about 10 classes of Python issues. The Bandit plugin documentation itself is, I'm not going to say it's great, but I think it's pretty good to explain the type of issues that Bandit is detecting. So you can go online and you can see, for example, if you're requesting with no cert validation, that issue that I talked about at the beginning, this is what an example of it looks like. Here's the problem, and then some resources if you want to go read further on it. And that is the end of my material. So I'd like to open it up for questions if anybody has any. Yeah. Can you repeat? Is Bandit driven by a bunch of regex? No, it's not driven by, I should have mentioned that. So the question is Bandit driven by a bunch of regular expressions? It's not. It takes an AST approach. And so basically what will happen is we load a file, and then we break the file. It's a Python source file. We break the Python source into abstract syntax tree, which is actually the tree that Python uses internally to understand the flow of your program. You'll see certain nodes, like a function node or a string node. Every element in Python has a node type associated with it. And so if we want to look, for example, for bad function calls, then we look at the function node and we say, okay, this is a subprocess popen, and then we can look at the argument and we can say, okay, it's got shell equals true. And when we have the two of those together, we know that we have a possible subprocess, command injection issue. So it's better than regular expression because with a regular expression, you might have a new line in there, and now, unless you wrote the regular expression craftily, you don't recognize it anymore. It forces everybody that's writing plugins to be, I guess, guessing all the ways that regular expressions might break. And there's a few other benefits to the AST approach that we implemented. Other questions? Thank you. Yeah, the question is, what reporting options exist for Bandit? So Bandit, in addition to the command line output that I demonstrated, will output JSON, HTML, CSV. I think there are a few more that I'm forgetting about too. But yeah, there's a lot of options. In particular for automation, we use JSON a lot because, everything can parse JSON. Yep. Remediation what? So the question is, do we have any plans to add remediation suggestions? I think that a great place to do that would be the Bandit plugin documentation. I think the format that we have lends itself to doing that well. And so I'm not sure that we've done it comprehensively for every plugin, but some plugins definitely do it. For example, we have an XML class of plugins off the top of my head. And the suggestion there is use XML may be susceptible to fork bombs and like all kinds of other XML attacks. Use diffused XML as our suggestion. So yeah, I think that we have it in some places, but I'd love to see it more prevalent in all plugins. Yep.
And so as you're tracking the stuff over time for code bases worked on by teams, how do you recommend, other than checking the results in the code base itself, or tracking the stuff over time?
Yeah, it's a great question. How do we track the remediation of these issues over time? Generally, part of it is the nosec stuff. So any issues that we actually determine weren't issues, we'll put nosec. And then generally, we have like offline ticketing and some automation we've built internally around it. But there's not anything for Bandit itself, and I would love to see more work in that space. Yep. Yeah, it's a great question. It'll go against whatever Python. Oh, sorry. Let me repeat it. Does it do just a module, or can you do other modules too, like your dependencies? By itself, Bandit will scan any pile of code you give it. It doesn't really understand that a certain set of source files make up a module. So you can point it at a directory, and it'll scan everything in the directory. What I would recommend in that case is I would actually recommend doing the dependencies separately so that you kind of have, and rather than having everything stuffed into one, you kind of have a different report structure. And then the other reason to do that, one of the limitations in Bandit right now is that you can only exclude one unit test path, and unit test for your dependency might be called something different than unit test for your project itself. So what you ideally like to do is you'd like to run each project separately, exclude unit tests, make sure you're getting good results, and then pile all the results into one central store, which you could easily do if you export like JSON or something like that.
A question behind you.
Oh.
Are there hooks for integration to IDEs like Spider?
The question is, are there hooks for integration into IDEs such as Spider? There aren't. I wish there were. It's something people have brought up very frequently. For example, PyCharm is one of the ones that we get a request for a lot. I don't think it would be very difficult to do, but nobody's done it yet. I would love to see it. All right. Any other questions? All right. Let's wrap it. Thank you.
Thank you very much, Travis. Special thanks from our sponsor, Fitbit, and here's your Fitbit. You got a Fitbit from our sponsor.